All right, this is a video on section 3.3, which is over lines. It's one of the basic concepts in geometry is that we want to be able to draw straight lines between points. And we will actually look at our lines that are in coordinate planes, which is our XY axis. And we're going to look at some algebraic methods that we can use to study these properties. So the big two things that you want to get out of this lesson is that if we give you a line in a coordinate plane, you should be able to find the equation of that line. So we want to be able to, if they give you the picture of the line or if they give you some information about the line, we want to be able to write that into equation format. And we'll have two ways that we leave that final answer, either in slope-intercept or something called general/standard form, depending on what book you consult. The second thing we're going to get out of this lesson is that we want to take an equation of a line and we actually want to be able to sketch the graph. Now, to be able to do either of these two things, we have to understand some concepts about lines. When you talk about a line, every line that is straight, so in other words, no curves, has something called a slope. Slope is the difference in vertical change over horizontal change. Some people memorized it as rise over run. That should be very familiar for most everyone. And it's found by taking two ordered pairs, x1, y1, and x2, y2, and you find the change in the y distance, which is the vertical change, and you divide that by the change in the x distance. So that'll tell you how steep your line is, and if it's slanted in an increasing direction, which would be a positive slope, or if it's decreasing from left to right, which would be a negative slope. So here's some pictures. All of the pink lines down here are decreasing slope. See how they're negative slopes? So as you go from left to right, it looks like you're going downhill. All of the blue slopes are increasing, so they are going uphill from left to right. Those are positive slopes. Notice that 5 is a much steeper slope, that's this line right here, than 1/5, which is a very slow rising slope. So that's because there's less vertical change here and there's a lot of vertical change here. So the formula we're going to use to find the slope when we're given two ordered pairs. So let's look at this first group right here. So it says find the slope of the line that runs through the given points. So our formula, remember, is m equals y2 minus y1 over x2 minus x1. This would be x1 and y1 because that's the first ordered pair, and x2 and y2. Sometimes to help out with signs, I recommend students do this. You make blanks with a minus sign between them on top and bottom. That way you don't mess up any signs between like a negative that's being subtracted. So y2 is 6 and y1 is -1. X2 is 5 and x1 is also 5. So notice we get 6 plus 1 on top, but we get 5 minus 5 on the bottom. That is 7 divided by 0. Now, unfortunately, we don't actually call that a slope because, well, it is a slope, but it's not something we can actually measure. We call this an undefined slope because that means we actually can't know what the slope is because it's dividing by 0, and we don't do that. So this happens when you have, by the way, just as a side note, this is a vertical line. We'll formally define that in a minute, but that's when that happens. So let's look at our next one. So m equals, so we have x1, y1, x2, y2, y2 minus y1 over x2 minus x1. So this is -3 minus -1 over -6 minus 4. That becomes -3 plus 1 over -6 minus 4. That's -2 over -10. You have to reduce this down, so we need to first of all realize that a negative over a negative is a positive, and 2 and 10 are both divisible by 2. So this is actually a positive 1/5 for slope. And then the last set. Go ahead and set up our formula for slope. This one would be -2 minus -2. And then over -3, take away 4. So this is -2 plus 2 over -3 minus 4. That's 0 over -7. 0 on top is okay. You don't leave it like this, though. You actually write that the slope is 0. This one happens when you have a horizontal line. So again, not formally defined yet, but it's a good side note to talk about that now. So vertical lines have undefined slope, horizontal lines have zero slope, and anything that's not undefined or zero is a slanted line. Okay, so that's how we find slope using the slope formula. So this is the formal definition of the horizontal and the vertical lines. So notice a horizontal line is parallel to the x-axis. So they've got a picture of it here. It's this blue one. And it has a y-intercept of wherever it crosses the y-axis. And its slope is 0. No rise, but lots of run. The vertical line is parallel to the y-axis, so it's going up and down. A is going to be whatever the x-intercept is going to be wherever it crosses the x-axis. And that's its equation, by the way, too. This is important to note here on both of these. The equation of a horizontal line is y equals a number. The equation of a vertical line is x equals a number. They don't contain both x and y at the same time. What that means is that you're looking at when you have, we're going to have slope intercept in a minute. This is going to be what you get when you have a slanted line of some kind. You'll have both x and y. So if you have just y or just x, you're dealing with one of these special cases. And the vertical line has lots of rise but no run, so the slope is undefined. Okay, so we want to graph some of these. You could do a table of values, but since we are savvy enough to hopefully have some memory of y equals mx plus b, I'm going to go ahead and teach it using that method. Just going to use different colors for each one. So before we formally define that, let's just see if we remember what those things stand for. Y equals mx plus b is a linear equation. We know it's linear because x and y are both to the first power. There's no weird symbols like square roots or absolute values, and there's no powers higher than 1. So that means that this is linear. If you have a linear equation and this is solved for y, that's the key thing, then the number in front of x on the other side is the slope, and the constant is the y-intercept, always the y-intercept. So it's on, and I always think about how the stalk of a bee goes up and down. So that's, that's on the y-axis, which goes up and down. So for this one, this would have a slope of -2/1. I like to write the over 1 so I can do my rise and run. And this would have a y-intercept of 0, -1. So we'd come down here on this one, and I'm going to do it in red because remember that's what I've marked here. I come down to -1, put a dot, and this slope, okay, so let's talk about slope for a minute. When you have a negative, you can either choose to put it on top or you can choose to put it on bottom. The top number is the rise, so it always tells you up or down. So this would be down 2. The bottom number tells you run, so this is a +1 down here now, so this would be right 1. If you switch it, you're still going to get the same line, but you're doing things in the opposite order. So this would say up 2 because you have a positive on top, but then left 1. So we're going to do both. So we're going to go down 2 and right 1, and then we're going to go up 2 and left 1. And draw the best straight line I can. I don't have a ruler on this computer, but do the best we can. So there's that line. The blue one has the same slope, but this time your y-intercept is 0, 3. So 0, 3, and down to right 1 or up to left 1. If you remember those two types of lines, when they don't touch and they have the same slope, those are called in geometry parallel lines. And then the final one has a different slope, so this is up 1, right 2, and this is 0, 3 again. So I still start at 0, 3, but this time I go up 1 and then right 2. If you wanted, you could do the opposite, which would be down and left. So notice this one is crossing these two, and I didn't have a ruler, so it doesn't look perfect. But when the slope is, notice this is -2/1, this has been flipped, and the sign has been changed. We'll formally define that in a minute as a perpendicular line. So anything that has that reciprocal and opposite sign as its slope would be perpendicular to the others. Okay, so we have some formulas that we need to talk about, and you're going to have these memorized. The first formula is the point slope formula. It is actually not usually how we leave our final answer, but it is the gateway to getting to the other two formats. Typically, and you can use, actually some people do slope-intercept for everything, and that's fine too, but point slope is actually a lot easier to manipulate into both formats, so it's a good one to know. And this is the point slope formula, so I'm going to highlight it here. Y minus y1 equals m parentheses x minus x1. That is found by letting one of the y2 and the x2 that used to be in the slope formula, because this is just the slope formula manipulated, have been made stationary letters of y and x. So when you plug into this, you only plug in for these three parts. You leave the x and the y variables. The slope-intercept form, that is usually a final answer format that you would leave your final answer in, and that's the y equals mx plus b. And then depending on your book, ours calls this general. A lot of books call this standard form. So I'll put in here standard is another name for this sometimes. We'll be using general on our, test questions, so make sure you know the word general though. Is all the x and y are on the same side together and it's equal to a constant, and there's a couple things about this. No fractions. So if there's fractions, you have to clear them out. It's okay to have fractions in slope-intercept. And usually we like the x to be positive. And that means if you end up with a negative x out front, you just multiply everything by -1. Not every book adheres to that last policy as fact, but the fraction thing is an absolute. So if you're ever doing a WebAssign question and for some reason it's not accepting your answer, they may not be making you change the x out front to be a positive. So that is a possibility. I prefer that you make the x positive for paper pencil test. So here's some things we're going to be doing. Steps to finding equations of lines. So if we're trying to write the equation ourselves, so they've asked us to provide the equation, the first thing you want to do is make sure you have the slope. So if you already have the slope, you just move on to the next step. So if you don't, there's possible ways to find the slope. If you have two ordered pairs, you're going to use your slope formula. If you were given a graph, you can count the rise and run physically by counting how much it's moved. Positive slopes, remember, look like they're going uphill from left to right. Negative slopes look like they're going downhill from left to right. If they've given you an equation already, you can solve it for y equals mx plus b. So you can put it in slope-intercept. That way you'll be able to locate the slope in front of x. It will not give you the slope until it's y equals, though. And so if you're writing an equation, find slope first. Use the point and the slope, because usually they have to have given you some kind of ordered pair. Put that into your point slope formula. You could also plug the point and m into the slope-intercept and solve for b. That's another method. Solve for either slope-intercept or general form based on the format that they desire in the question. They will ask you for a specific format. And then we already talked about parallel and perpendicular. If two lines are parallel, they are going to have the same slope. That's the key word there. So same slope. If two lines are perpendicular, I don't really like their formal definition, so I wrote my own. They have to be negative reciprocals of each other. Another word for that is opposites reciprocals. So if one of them is -3/5, the perpendicular, which we use a little symbol, this is for perpendicular, would be 5/3. You flip it and you change the sign. So if you want to find an equation of a parallel or a perpendicular line, you have to still find the slope of the original line, and usually that means you manipulate it for y equals mx plus b. You transform the old slope into the new slope, and they will have given you a word in the problem, either parallel or perpendicular. If it's parallel, you just keep the same slope. If it's perpendicular, remember you flip it and you change the sign. And then you use your given point and your new slope into point slope to find the equation. Okay, so we're going to jump right in and we're going to do some examples. It says find a general form of an equation of a line through the point A that satisfies the given condition. So we have a point here and we want it to be parallel to the x-axis. So if you think about that, parallel to the x-axis means that that line is horizontal. So horizontal lines don't require any special thing to solve. If you've got the point, you already know what it is. Horizontal lines are always y equals a number. the number is the y spot in this. So this is just y equals 2. If you want one that is perpendicular to the x-axis, so this one would be the perpendicular case, then you need a vertical line. Vertical lines are just the x number, so x equals -4. So there's not much to do for this specific set, but just knowing parallel or perpendicular to the x-axis is telling you either horizontal or vertical line. So both of these are solutions, this one for this part and this one for this part. Okay, this is the first one that's a slanted line. So we have a slope of 5, and they actually already gave you the y-intercept, so this is b, so you could go plug this straight into y equals mx plus b if you wanted. But if you didn't recognize that, you would write it as y minus y1 equals m parentheses x minus x1. So this would be y minus -2 equals 5 parentheses x minus 0. Distribute that 5 and also change this to a +2. But 5 times 0 is just 0. So subtract the 2 over. Oh wait, we're supposed to read our directions here. See? I was putting it in slope-intercept form. Our directions said general form, so it's a good thing I looked back up there. So to put this in general form, you'd have to move the 5x over and the 2 over. So I would subtract over the 5x and subtract over the 2 to the right side. So now this has the x and y on the same side and the 2 on the other side. And then because that has a negative out front, I don't like that. I will probably change all of my signs. So that would be general form. So this is general. Slope-intercept would have been, they didn't ask for it, but just so we see the difference, would have been just moving the 2 over. You wanted y by itself. So see how they're slightly different based on which way you want the final answer to look. Okay, let's look at C. They gave us an x-intercept, which is another ordered pair, so you can write that as 5, 0, because remember x-intercepts are number, 0. So now we have 2 points, but we don't have a slope, so we need to find the slope. So we use our formula for slope, y2 minus y1 over x2 minus x1. This is y2 is 0, y1 is 6, x2 is 5, and then this is -1. So that is -6 over +6, so that's -1. So there's my slope. Once you have your slope, you can use one of the points. I'm just going to pick the first one and plug it into point slope. So y minus 6 equals -1 parentheses x minus -1. So that will be x plus 1. Need to distribute that -1. And then I'm doing, again, general form, so I need to move the x over by adding it and also add the 6 to the other side. So it looks like I'm getting x plus y equals 5. Okay, for D part, it looks like we want to get a parallel line. When you're dealing with parallel or perpendicular, you usually have to find the slope of this first, then make the slope parallel or perpendicular, and then finally you use the point that you were provided with. So for step 1, we're going to find the slope of this by solving it for y. So this is 3y equals -x, because I'm subtracting the x over, plus 1, and then I'm going to divide everything by 3. So that's y equals -1/3, because there is a 1 on top there, x plus 1/3. Here's my old slope. Step 2 tells me I want it to be parallel. Parallel, which we have a symbol like that for parallel, it's 2 lines side by side. Parallel means you keep the slope the same. So that means it's still going to be -1/3. So there's that part. And then finally, we get the actual equation. So these circled parts aren't really answers to the problem. They're me working through each of my 3 pieces. So y minus 5 equals -1/3 x minus a -3, so that'd be x plus 3. Okay, here's a little trick. If you're dealing with fractions in the point slope form, you can get rid of them by one small thing. If you multiply both sides by the denominator of this fraction out front, that will clear out that fraction right there. So all you have to do is distribute the -1. On this side, you will have to distribute the 3 that you moved over. So 3y minus 15 equals -x minus 3. To get this in general form, we add over x and we add over 15. So this would be x plus 3y equals 12. So there's my new equation. Okay, perpendicular. Similar steps, still 1, 2, 3, kind of working backwards, but this time you have to make the slope perpendicular. So we start off with our equation that they provided. That was the old line. We solve that for y. Which I'm getting -3/2 x plus 7/2. There's the old slope right there. For making it perpendicular, you need to flip that and change the sign. So 2/3, and it's positive now. And then finally we use our point slope formula. So y minus 5 equals 2/3 x minus 4. So I'm going to multiply both sides by 3 to get rid of that fraction on the right side. That will leave me with just a 2. So notice this gets canceled and this is now got a 3. So this is 3y minus 15 equals 2x minus 8. I'll subtract over the 2x and add over the 15. So that's -2x plus 3y equals 7. If I want this to have a positive out front, you just change all the signs. So that one is now in general format as well. Okay, for example 4, this is the first one they've asked us to put the final answer into slope-intercept, and there are 2 of them, I believe, to work out. So just to show you how to put a final answer into slope-intercept, this one is x-intercept, so that'd be -5, 0. The y-intercept is 0, -1, so now those are just ordered pairs. So we need to find our slope. So -1 minus 0 over 0 minus -5. That's -1 over +5 because that's a minus a negative. So that's my slope. And then I can actually, just since I know the y-intercept, remember y equals mx plus b, this stands for y-intercept, and that stands for slope. So this is just y equals -1/5 x minus 1, because the y-intercept is a -1. So if you already know the y-intercept, you don't really need to use point slope. All right, let's look at b part. So we need to find the slope first. So m equals 7 minus 1 over 3 minus -2. So that's 6 over 5, because that would be plus 2 overall. And we would use our point slope formula here. So y minus 7 equals 6 over 5 x minus 3. So I used this point. It doesn't matter if you use A or B, because once you've solved, at the end, the answer comes out the same. So I'm going to multiply both sides by 5 to get rid of that denominator on the right. And this would be 5y minus 35 equals 6x minus 18. Subtract over the 6x. Add over the 35. And let's see, what is 35 minus 18? 17. So this is -6x plus 5y equals 17. Or like I said, if we don't like a negative out front, and some books do not, I prefer also not to have a negative out front, then we change all of the signs. Quick way to check yourself to make sure your equation is correct, because we haven't really talked about that. Oh, sorry, we're supposed to put this in slope-intercept. Back up for a second. Oh no. Let me fix what just got erased. For some reason it erased some of my work. That's 18. Okay, so we don't need this last line here. So if we're going to slope-intercept, so you got to pay attention. you would move everything over to the right. So we're going to add the 35 first. So this would be 5y equals 6x plus 17, and then we divide by the 5. So y equals 6/5 x plus 17 over 5. Now, it would be easier to check yourself if you were in general form, but if you want to check to see if your equation is right, plug in the x value right here. That would be 18 over 5 because it's 6 times 3. 18 plus 17 is 35. 35 divided by 5 is 7. It should give you the ordered pair if you plug in the x. You should get the y value. Okay, example 5 is a special case, so we need to talk about it. This one says we're going to find the general form, so that's one key thing we need to focus on. So remember that means the ax plus by equals c of a perpendicular bisector. I'm going to do those in different colors because they mean different things. Obviously, perpendicular means that we need to flip and change the sign of the slope. Bisector means something different. Bisector means that our equation has to go through the midpoint. So we have to find two things from this set of ordered pairs. We have to find a slope so that we can make it perpendicular, and we have to find the midpoint. So I'm going to do the midpoint first. So remember midpoint formula, you add the x's together, you cut them in half, you add the y's together, you cut them in half. So this would be 4 plus negative 2 divided by 2, and 2 plus 10 divided by 2. That is 2 over 2, so that's 1. 12 over 2, which is 6. This point right here is crucial. We have to use that in our final equation for point slope. If we don't, then we don't go through the midpoint. You don't want to use either one of these in your point slope formula. You want to use the midpoint so that it is a bisector. And then we need to find our slope. So we're going to use the same 2 points to find the old slope. So 10 minus 2 over negative 2 minus 4. That is 8 over negative 6, which reduces down to negative 4 over 3. I want a perpendicular slope, so that would be positive 3 over 4. So now I have found both pieces of information I needed. The midpoint is the bisector. The slope I just found and did the opposite reciprocal is the perpendicular part. You take those two pieces and that's what you plug into your formula. So notice, just to keep consistency here, there's the slope of the perpendicular part, and those two numbers, remember, came from the midpoint. Multiply both sides by 4 to get rid of that, because we're going to general form this time. It's also easier to do everything if you just don't have a fraction. So this would be 4y minus 24 equals 3x minus 3. Subtract over the 3. Add the 24, and we're getting negative 3x plus 4y equals 21. So my final answer, I'm going to write it up here since I'm running out of room down there. I would change all my signs. So 3x minus 4y equals negative 21. And there you have it. Okay, for example 6, we're going to be graphing some lines. So it says use slope-intercept form to find the slope in the y-intercept and then graph the line. Now, the good thing about having slope-intercept to graph is that the first thing you're going to do is plot B on the y-axis. Step 2, you're going to use M to rise and run to a second point. You have to be careful there because you have to pay attention to your signs. Are you going up or down, right or left? And then 3, connect with a line. Okay? So we first need to get this to be solved for y. So I'm going to add the 4y over just to get it over here and be positive. And then I'm going to subtract the 7x over. And then I'm going to divide everything by 4. So that reduces down to a negative 2 for the y-intercept. You're going to plot that first. So go down to negative 2 on the y-axis, put a dot. Your slope is -7/4. So you could choose to go down and then right, because that's how it's typically written. Or you could write that as 7/-4, and that means you could go up 7 and then left. I'm going to do both. So down, you don't have to do both, you just need a second point. But down 1, 2, 3, 4, 5, 6, 7. Notice I went 7 from the -2, and then right 1, 2, 3, 4. So there's my second point there. Or I could have started at -2 again and gone up 1, 2, 3, 4, 5, 6, 7, and then left 1, 2, 3, 4. Notice that all three of them are in the same line together. And the arrows on the end mean that it continues on forever. Okay, let's look at the next one. So we need to solve this for y if we're going to use the slope-intercept method. So I'm going to just rewrite this. This is -5y. I'm going to subtract the x over, and then I'm going to divide everything by -5. So this would become +1/5 x, and that's a negative over negative again, so that's going to be +3. So my y-intercept is 0, 3, which is right here, and my slope is up and right because they're both positive. So up 1 and then right 1, 2, 3, 4, 5. Okay, for 7, we want to find the equation that goes with each picture. So if you can locate the m and the b, you should be able to find them. Remember that horizontal and vertical lines are special cases. So this is vertical. Verticals are always x equals a number. The number is where it crosses the x-axis, so x equals -2. Let's go ahead and do the horizontal one as well. Oh, I didn't have a horizontal. Never mind. For b, we need to locate b, which is the y-intercept, which looks like it's supposed to be 0. And we need to locate another point so we can count the slope. I believe this one, it's a little off, but I believe it's supposed to be 1, 1, or 2, 2, or 3, 3. Any of those would work. So up 1 and then right 1. You count the slope. So up 1 from the bottom, right 1, which means my slope is 1/1, or just 1. So my line would be y equals 1x plus 0, which we could just write as y equals x. Let's look at C. Okay, so we have a b of -2, and another point looks like at 3, -1. Typically they would give you the points, but this is hard to do on a Word document. So the b, remember, is -2. We just need this to count to another point. So this is up 1, and then we need to go right 1, 2, 3 to get to that point. So that would be a slope of up 1 is positive, right 3 is also positive, so 1/3. So the slope is 1/3. So my equation is going to be y equals 1/3 x minus 2. That's my m and my b. D is the last one of these. So b here is 1, because that's where we cross the y-axis, and I believe our second point was supposed to be this one right here. Again, it's hard to tell, but I'm estimating if we give you something like this on a test, we would have 2 dots for you already marked. So this is up 1, 2, but then left 1. So up, remember, is your rise, so that'd be a +2 on the top, and left is a -1. So this is actually a slope of -2. So my line equation would be y equals -2x plus 1. Okay, and then the final question on this set of notes is dealing with mathematical modeling. Two variables, x and y, are linearly related if you can come up with a y equals mx plus b situation. For example, things that we think grow linear. Now, a lot of what you have to remember about models is that they are using a small set of data, and a lot of times the line doesn't stay a straight line forever, but it's a best rough estimate. Sometimes other models are better than just a straight line. But we're going to assume that this is linear because they're actually they're telling us in the problem that it is. So a baby weighs 10 pounds at birth. So think about that as being age 0. 3 years later, so that's age 3, the child weighs 30 pounds. Assume that childhood weight in pounds is linearly related to age t in years. Okay, important thing. Whenever they write things like this, the first thing they mention is y. What it's related to is x. So we're doing years as x and pounds as y. So we have two separate ordered pairs here. 0, 10, because that's 0 years old, I was 10 pounds, and 3 years old, I was 30 pounds. So we should be able to use this to find slope. So that would be 30 minus 10 over 3 minus 0. That's 20 over 3. Then if I wanted to write this as an equation, I already have my y-intercept because this is 0, comma number. I can write, they want us to write y as w and x as t, so we're going to write it like that. So w equals 20 over 3t, and then this would be plus 10 pounds at birth. Let me erase that y and put it a little higher. So that would be my equation based on this model. What is the weight of the child's 6th birthday? Okay, so now we're plugging in 6 for t because it's age. So then 6 and 3 reduce. So that would be 20 times 2. That's 40 plus 10. So it looks like the child would weigh 50 pounds. And then what age will the child be when it weighs 70 pounds? So that's going in for W in our equation. First thing I would do here is I would actually subtract the 10 over to get this 20 over 3t by itself. Then we can multiply both sides by 3 to clear out the fraction. That'd be 180 equals 20t. Divide by 20 and t would be 9 years old. All right, that's the end of this video.